Hi, this is Superintendent of Schools Bill Olson, and welcome to Education Matters, a program about the people, the students, and the programs in our school system. It's a pleasure to have you viewing today, and we have a very, very special program for you. We have Bill Bowen, who is a physics teacher at Westford Academy, and the distinguished members and award-winning members of the Westford Academy Robotics team. And so, Bill, welcome to the program.
Thank you for having us.
First of all, tell me a little bit, before we introduce all the students, tell me a little bit about how long you've been at Westford Academy and what you teach and what got you into robotics in general.
Sure. I've been at the Academy for 20 years now, a veteran, I guess I would say. I teach physics, quite a variety of classes. We have three levels of physics at the Academy, and I teach all three of them, advanced placement. And a few years ago, I was corralled by a student that wanted to participate in the US First, one of the robotics programs. And he did such a good job of selling that I couldn't say no to him. And long story short, here we are 3 years later, and quite a few hours of investment, and a pretty good level of success too.
Well, you have had a lot of success. In fact, Bill and the team members were at a recent school committee meeting and demonstrated how the robots work, some of the competition, and we're going to talk about that today. And I'd like to introduce members of the team, and starting on my right is Nico Jurek. Nico, you're a junior at Westford Academy, right?
Yes, I am.
And initially, what got you interested in robotics?
Well, I really want to become a computer programmer. Of course, I love video games. I'm always like, oh, how do they do this? How does it go behind this? And so that got me kind of interested into this, and plus I kind of need a club. But and that's what primarily got me into this. And I announced I want to kind of change my career course, going to like robotics, because I've seen like all the good stuff it has gone. Like I have like medic, military, really anything can be put into this, and I think it's just a huge field, but it's just pretty good to go.
Good. And we have Sashwat Mishra, right? Sashwat, did I pronounce that correctly?
Yes, you did.
Terrific. Now, you're a sophomore at Westford Academy.
I am.
All right. And how long have you been involved with the robotics team?
I have been involved for this team for 2 years. However, I've also done another level, which is for younger students, for 2 years as well. And that's what got me started. The other program's called FLL, First Lego League, and from there, I transferred onto this high school robotics team. So,
great.
After good success from there.
Terrific. Well, we have also Shiva Nathan. Now, Shiva, also for those watching the program, is the young man who has developed a robotic prosthetic arm. Is that correct?
That's correct.
And so now tell me a little bit about when you became interested in robotics.
Well, I've always been interested in robotics and technology, and so I've always loved that sort of thing. In middle school, there was a short pilot club for robotics. I joined that. Then there wasn't enough interest the next year, so that kind of fell flat. I did some robotics by myself over the next few years, which led into the construction of the prosthetic. And then this year, I decided to join the robotics team because I always want to be part of an official robotics challenge club.
Great. And we have Matt Raboy. Matt, you're the only senior in the group, right?
That's right.
Terrific. And tell us about your history on the robotics team at Westford Academy.
Well, I joined the team 3 years ago because I was interested in engineering and design in general. I wanted to find an activity that would help me foster that and learn more about it.
Good. Now, I understand you're going to Penn State.
That's right.
Year, right?
Yep.
And what would you like to major in?
I'm going to be majoring in nuclear engineering.
Very interesting. Has that been a passion of yours for a while now?
It has been for a few years. I've been interested in that, and just recently I've decided that's where I'd want to end up spending most of my future.
Great. And because there are relatively few colleges and universities that have nuclear engineering.
That's right. That's why I have to go all the way to Penn State to do it.
That's right.
And he did also receive a scholarship for that.
Right. I have a scholarship from the Navy to do that, so for the next 4 years I'll be training with them, and then after that I'll be graduating and getting a job in the Navy.
Perfect. Well, let me congratulate you in advance for serving our country.
Thank you.
All right. Next, we have Vic Rao, and Vic, you're a junior at
I
Westford
am a
Academy.
junior, yes.
Tell me when your interest began in robotics.
Freshman year, I was kind of just walking around in the halls, didn't have much to do, and I saw flyers around one day, and they were like, "Oh, we have a robotics meeting in Mr. Bowen's room," and I was like, "Oh, that seems interesting," because I've always had a passion for robotics and building things and putting things together. I have a giant room of things that I put together in my house, so I was like, "Oh, I'll check it out," and I ended up here.
Good. And next, Alex McKinley, and Alex, you are a junior at Westford Academy, right?
Yes.
Tell me a little bit about your involvement in robotics when you first became interested, and if you specialize in anything in particular on the team.
Yeah, so I'm our team's head programmer, so I handle a lot of the software stuff. And I really became interested in the club when I heard an announcement, and I was like, oh, there's a robotics team. I wonder if I can go there. I wonder if I can go program, which is what I wanted to do and what I'm hoping to major in college. So I came, I learned the language. It's a lot of fun. And then this year, I was wanted the head programmer by Mr. Bowen.
Well, tell me a little bit more about, you mentioned the history a little bit, but some of the history in terms of your participation in fairs and competitions that you've been involved in both locally and regionally.
Well, we compete in the U.S. First competitions, and there are different levels to that competition. As Saswat said earlier, there's one for grades or ages 5 through 13. We compete on a little higher level than that. It's the First Technology Challenge, and in this particular challenge, we have to compete in a field. Every year the field is the same. It's always a 12-foot by 12-foot arena. And components in the fields change year after year, and so do challenges. And to give you an idea of that, last year's challenge was there were rings, and we had to go to an area that was holding a bunch of rings, and we had to be able to grab them, only allowed to take 2 at a time, and then move to another part of the field and place the rings in a tic-tac-toe type arrangement. And we got points depending on how high we placed them and the arrangements, and you got extra points for tic-tac-toes. There were other components to that game, but that was the most part how you scored points. This year they chose to go with a 2-inch by 2-inch block, and this game component you would pick up and put in different locations in the field, working with other schools and working in combination with other schools. And what's interesting about the competition is in that 12-foot by 12-foot arena, there are 4 teams. And you are paired up with one team that you may very well be competing against later in the day. And what's interesting about these competitions, and US First, their mantra is gracious professionalism. And what they really want you to do is to work with other teams, encourage other teams, and help other teams, even if they are competing against you. We had one team a couple of years ago, or last year, we lent them a motor because a motor burned out on their system, their drive system. We lent them a motor. A little bit later in the day, they beat us in one round using our own motor. I wasn't happy about that, but that's the nature of the competition. So the challenge for this year, for the US First here, was to take these blocks and put them into what are milk crates. If you guys could hold that up, and we'll demonstrate that. There's a seesaw arrangement that, as you can see, we have red and blue tape, and so there are blue teams and red teams, albeit that all of these should be one color. And so the blue team would have one seesaw like this, and the goal is for them to grab as many of these blocks as they can and drop them into these milk crates. These milk crates would be sitting, or the seesaw would be sitting about 16 inches off of the ground. You get different points for putting them in the outside crates. You get 3 points. On the inside crate, 2 points. And as I said, this thing is a seesaw. It would rock back and forth. And if at the end of the competition your seesaw is balanced, you get a bonus of 50%. In addition to that part of it, there is also another part in the field which is a chin-up bar, and it is located 31 inches high, and you have to design a robot that can reach up to that 31-inch height. The challenge with that is at the beginning of this competition, your robot must fit into an 18 by 18 inch box, cube. Those are the dimensions you're given. Your robot can't even touch the sides of that box. We don't like that box. Every time we go into competition, we have worries that we're going to get there.
Quite close then.
It is quite a challenge. And so, of course, if you have an 18-inch high robot, you need to build components that can extend out of your robot up to the 31 inches. And so last year, as I said, the ring one, you actually had to get up to 46 inches, I think it was the top challenge.
That's quite a height.
It is, and so those are two components of the game. There's another component of the game which is an autonomous section. Every single game runs with a 30-second period of time in which the robot must be programmed to run autonomously. You create the computer programs to move around the field, to manipulate game pieces, and try and score some points during that 30-second time. After that 30 seconds, the judges would then stop the competition. They step into the arena and award points based on what it was your robot did. They then step out of the arena, and a final 2 minutes of what's called tell-up time or human-driven time. And as you can see, Vic and Matt have a game controller, what is just a simple PlayStation or Xbox game controller. And the kids have programmed all the buttons in these controllers to work different components on the robots.
Great. Now I know we're talking about software, hardware, components, and also an engineering process to put everything together. So if you want to kind of work with the members of the team here, and let's talk about and take a look at the robots, how they're constructed, how they perform, and then we'll talk about some possible real-life applications of machines such as this.
Sure. So the competition itself is explained or presented to us all in September, early in the school year for us. And in day one, we started, well, Vic and Matt, why don't you guys tell me, what did we do on day one?
So basically, the first week we just had everyone sit in the desks in the classroom, and we just said, everyone come up, put an idea on the board, and then we can vote and see who likes what. And then from there, we took the ideas that everyone liked, and we put them off to a side, and then we allowed everyone who wanted to build get some experience building, putting parts together, taking things apart, and so on and so forth. And people who wanted to program, we sent them over to Alex, and Alex showed them the commands and how to do everything. And then after a few weeks, then we started getting exactly what we want to put on which robot, who wants to work on what, and then we ended up with the robots that we have.
Those brainstorm sessions were really important for us too, the first few days.
And very characteristic of a work site environment where you have brainstorming sessions and work teams that are working to solve particular issues, and also dividing up all of you in your interests, the old concept of specialization and division of labor, all processes that you see in the private sector, and so you're beginning to develop those very well at a young age. So tell us a little bit about what they can do and how they do it here.
Okay, so we're going to demonstrate these. Good to go.
So we have our normal drive system. If we want to get a shot of the robot. The robots can drive around like any which way they feel like. And then about that chin-up bar that Mr. Bowen mentions, they can reach up quite high. So this year, what we decided to do for our chin-up, instead of grabbing the bar and pulling, we decided what we would do is grab the bar and then lift our wheels up. So it's kind of like a cheating pull-up. But yeah.
So basically what happens is the little servo arm part up here that we saw go earlier will hold on to the bar, and then after we're sure that we're on, then we just lift our wheel system with the bevels here, and that brings our entire robot up.
Good. If we could get a shot of the robots, I'd love the viewers at home to be able to take a look at the product of all of your work.
The different components of the robot, one of the things that our designers came up with was we decided really early in the year that the chin-up bar, trying to lift the whole robot up was really going to be quite a challenge. And so what the guys and what we purchased this year was what is a worm drive system, and we have some rack and pinion gears on here as well. And the worm drive just runs the rack and pinion. There really is only one drive motor that is spread out. That drive system is spread out to all 4 of those vertical posts. And that vertical piece that goes up, it really doesn't support any weight per se. All that has to do is just simply latch onto the bar, and the strength of the system is the fact that it pulls the wheels up from the bottom. It is quite a robust robot. The other robot approached it in a different manner. Nico, if you want to flip the arm up. And the other robot approached it in a different manner. In this one, what we did was we built an arm, and the arm just simply lifts up. Again, we had to fit inside that 18-inch area. The arm goes up, and so this one would drive and lift the arm up and latch on. There's another component here, our double hang system. It turns out that in the competition, if you get one robot to hang on that chin-up bar, you get 50 points for that. If you can get 2 robots to hang, you would get 100 points. The trick, and this is what US First does, is they give you a design constraint which says that each robot has the equivalent of 2 feet of area, 24 inches, but your robot is 18 inches wide. So you can't drive 2 robots up and park them side by side. There's not enough room there. You have to stay on your own side of this chin-up bar. So what this group decided was they figured out that they would put an extra little arm on the robot extending out. The robot hooks on here. This piece reaches out past our robot to allow our teammates to go up and latch onto that piece. So
tell me a little bit about the construction. Are there, I know you've got dimensional tolerances that you have to meet. Are there guidelines in terms of designing and building these, or are you pretty much, as long as you stay within the confines of the measurement criteria, can you design and build something in accordance with your own specifications?
Nico, you're a parts manager.
Yeah, I am the parts manager for this, and actually, you do have specific parts you have to stay to. Like, I know we can't use like glass or like sheet or some kind of sheet metal or some other parts, but we do have on the back of here. In the back of here, we have a block of wood that we use to keep ourselves stable because we knew that our robot was a little bit back heavy. But we also have plexiglass, which I don't have on right now because I was changing it. Neither of them do, but we have like zip ties, we have glue, we have foam, we have cardboard. You can't really like manufacture your own parts, so you have to use your own little Tetrix bot, which is all this is bought. You just only add on a few extra things.
So the Tetrix, as he mentioned, it's owned by Lego, and the brain on both of these robots is a simple Lego Mindstorm brain that we're hooked up now by way of Bluetooth on them. But all these components are considered Lego components. And we purchased them as a kit, and then we bought extra parts through the years. We go through a lot of parts. We do have to cut them, and we don't necessarily manufacture parts, but everything that's on here, there wasn't a kit that told us, here's how you build it. These guys literally brainstormed, designed, built, tested, rebuilt, have had to take apart and fix on occasion. This is all completely their design.
You've done a fabulous job. About how long does it take to build each robot?
Well, the challenge is usually unveiled around September time, and it's hard to say exactly when we finish building the robot. They're never really finished. We'd probably be comfortable with going to a competition by around November or December, but even after then, if we advance from there, we'll be building well into March or April even.
How often do we meet in a week?
Oh, every single day. And then Fridays, sometimes we'll go extra late, and then even before our competition, we've been known to stay till like 10 o'clock. There's a funny
I remember
story.
our record
about-
was 11, 12 o'clock at night.
11. The
Yeah,
custodians
like
would
11,
be-
11:30 o'clock at night was our record.
That really speaks volumes about the passion that you all have for this. And the importance to me is that innovation is absolutely essential to the long-term economic health of our country. And you are really innovators at a very, very young age, and you've put together something that's very, very sophisticated here and very impressive. And what types of real-life applications could we expect? Now, we know that robots presently do a lot of things. They do a lot of things in industry, in the manufacturing process. They're used oftentimes in law enforcement with regard to checking for potential bombs and explosives. Is there any other applications that you've thought of that robots, whether it's these or other sophisticated robots, could be used for in the future?
Well, we were actually asked the same question at our last qualifier, and one of our other members, Jeffrey Thomas, he came up with an idea. Apparently, he's been thinking about it for a while for fighting stuff. So we just send robots in because robots don't need a source of oxygen or anything else to like protect themselves, so they could go search the area and so on and so forth.
Now, it's interesting you say that, Vic, because when you demonstrated these to the school committee this past week, one of the first things I thought of is how could these be used in school security? You know, to sort of, if they were an intruder in the building, if we had a camera on it and someone moving this in a remote and safe location to navigate through the hallways to pinpoint the location of the intruder, that would help law enforcement. So I guess I'm going to present that challenge to you also in terms of how can we potentially use this for school security application?
School security, like you said, like cameras. You could also put maybe like a paintball gun or like a taser on it or something like that. Like it's like a simple kind of mechanism. It's all about. It's really basic. You can really do like right here. We can touch a camera on it and drive it off. There's also a bunch of other capabilities. Like I saw a medical robot that was doing precise movements inside of a person's actual body, and so I'm just like wowed by that. But Sauce, do you have any ideas?
So pretty much, basically, we can use multiple types of sensors to locate, because these robots, like especially during autonomous, like in our own robotics, we have to navigate the robot without any human interference. So what they have to rely on is sensors. And we can use those sensors or similar sensors to detect people and everything, and even intruders and weapons and so on and so forth. And it can be very useful for
Well, this is a fascinating field, and I can't tell you how impressed I am with the depth of knowledge that you all have, and of course the quality of the advisor you have here and the person to work with, because you know there's lots of curriculum out there in terms of math, science, English language arts, etc. But it takes people, very well qualified and highly qualified people to deliver that curriculum, and that's what the school system is all about.
One of the things that I'm really proud about is these guys, aside from the amount of hours that they put in law getting these robots up and running and making them work and fixing them, they also have done, we were invited by Carol Shestock, one of our former curriculum coordinators, to be the keynote speaker at the Townwide Inventors Fair. And these guys put together the entire program that they did, where they demonstrated the robot and talked to all of these elementary school kids up to middle school age kids how it was that they engineered and designed these robots. And they do things like that in addition to also working with some of the FLL, which is First Lego League teams, and a couple of kids sponsor those. Saswat, you have a trip coming up this spring with an FLL group?
I do. So what we do is we mentor these FLL teams, and as a matter of fact, they've actually done quite well. So it's,
How well?
Oh, one of the teams even placed first in the state. So they're like the only team from the state that is going to the national level.
Outstanding. Now, is that any of these trophies associated?
Well, these trophies were trophies that both of these robots won. The 7876, this one with the arm on it, won what is called the Inspire Award. And when we go to a competition, we compete with what could be 20, 22 other teams. And at the end of the day, teams rank out in first place, second place, and so on and so forth. But they give judged awards, and both robots won what is called the Inspire Award, which is the top-rated award that they give at a competition. It's a judged award, and both teams won that award. It is, in essence, an award that says you are doing exactly what we want all U.S. First teams to do with respect to community outreach, design, building a robot that competes well. It doesn't have to win, but it has to compete well. And then being a good team and working with other teams in competitions. I really am very proud of these guys and all the work that they have done and their level of success.
That's outstanding. Bill, how many other high schools have robotics teams?
I'm not sure. There are a lot. The state of Massachusetts, both robots have qualified for the state finals, which are going to happen on March 8th, Saturday, March 8th. And there are 32 teams from across Massachusetts and New Hampshire and Maine that will be competing there. If we manage to advance from the Massachusetts state finals, we would go to what's called a super regional. That happens, I believe, April 1st in Pennsylvania. And after that, if the robots do well, or any one of them does well, then we would advance to what is the World Championships, National Championships, World Championships, which are held in St. Louis, Missouri, on the second week of April, I believe. And as I said, Sasquatch will be accompanying that FLL, First Lego League group, which won first in Massachusetts in April, to that competition in St. Louis.
We have about 1 minute left in the program. So, Bill, I want to thank you.
Thank you very much.
Nico, Sasquatch, Shira, Matt, Vic, and Alex, congratulations. And Jeff and others who are associated with the team, congratulations on an outstanding job. And the last 30 seconds or so, if there's any way to activate, I guess I'm going to call it 3565. Let's see what it can do. And as we're doing this, this is Bill Olson. I want to thank you again for joining me on another program of Education Matters.
Moving on. Just about all we do.
There we go. Just love the second.
That goes so fast.
It really does a good job with flag race.